Velkommen til et nyt webinar i DMN. Normalt er det jo Ben Lindhardt, der plejer at sidde her, men jeg har fået æren af at være gæstevært i dag, hvor vi har besøg af professor Akihiko Takahashi fra Chicago, DePaul Universitet i Chicago, som er berømt over hele verden for sit arbejde med blandt andet lektionsstudier, men især teaching through problem solving, som vi skal høre en del om i dag. Professor Takahashi, welcome to our webinar.
Well, thank you very much for having me.
So, Professor Takahashi, you're especially famous for working with lesson study and with teaching through problem solving, or TTP as we call it. In Denmark, as in most other countries outside Japan, when we think of teaching mathematics and Japan, we usually think of lesson study. But actually, the reason we do talk about lesson study and we know about lesson study is related to something that lies behind it, which we often don't know so much about. Lesson study was basically introduced to the Western world in 1999 when the book called The Teaching Gap was published. And based on that, there was an increasing interest in lesson study. But the reason that book was made in the first place was that researchers from especially the US, but the Western world in general, caught interest in how Japanese students could time and again, year after year, perform so well in international tests. And when they, during a very large research program, investigated what could be the reasons for this, they realized that in Japan there's a very different kind of teaching going on. This teaching is often known as structured problem solving or teaching through problem solving, which is the phrase we'll use today. But the good question is, what is teaching through problem solving, and why should we spend some energy on learning about it and perhaps consider to introduce it to our own countries? Professor Takahashi, please start your presentation.
Thank you very much. Well, the teaching mathematics through problem solving is a translation of the Japanese term 問題解決学習. The 問題解決学習 is learning through teaching, learning through solving problems. And there's, as Jacob said, there are several different terms used to translation of this 問題解決学習. But this time we're going to use the teaching through problem solving because the through is so important. That's a process. The Professor Sugiyama, one of the leading mathematics education researcher in Japan, I show in this slide the quote from this: simply showing the products of somebody's work will not help learners see the thought process of coming up with new ideas. Because we want the student to come up with new ideas to survive such kind of dramatically changing world, not just simply mimicking somebody's ideas to simply follow without thinking. So for those kind of future generation, we want them to think, but in order to do so, just showing the result of mathematics, which is formula or procedure, doesn't help them to be able to create it. So therefore, like Japanese mathematics education start focusing on the process of mathematics, and it has been long time. The development of TTP in Japan is started. TTP is teaching through problem solving, accumulation of major ideas from variety of researchers in Japan. And then the first, in 1958, the Japanese mathematics curriculum introduced a new term, mathematical thinking, in order to highlighting the mathematical process. And then the translation books such as Polya's How to Solve It, 1954, that was become one of the best-selling book in the mathematics education because everybody can be a problem solver. But before this book, many people think about it. Only the talented people can solve problem, and then rest of the world should follow. But the Polya's, if you help them in particular ways, everybody can be a problem solver. which we really want everybody to be a problem solver. And then the National Council of Teachers of Mathematics in the United States produced Agenda for Action, which is 1980s should be a decade for mathematical problem solving. And then 1989, US is producing all these, the standards and curriculum, and that impact a lot to Japanese education. So the Japanese working very hard during 70s, 80s, and 90s to make this happen. Although that the research recommended the problem solving is important, how can we help students to become a problem solver? That's a big question. And during the time, the NCTM, National Council of Teachers of Mathematics, produced a variety of documents, and then including this NCTM 2000 standard. They talked about problem solving being engaged in a task for which the solution method is not known in advance. That means same problem can be good for problem solving or not. If the student knew the similar kind of task already seen before, we do not call problem solving. We call exercise. But problem solving, we gonna give student the problem that he or she never seen before, and then lets them attack by themselves, so that the student can experience of this thought process to overcome, and then throughout discussion to come up with new ideas. And also, the document is said that good problem is give students a chance to solidify and extend their knowledge and then stimulate new learnings. And therefore, the problem solving should be an integral part of everyday lesson, not like the end of the chapter activities. So basically, the new concept should be introduced by asking students to solve a new problem. But this was very different from the mathematical classroom in Japan that time. And many teachers and then researchers kind of scratching head, how can we make this happen in the classroom? And then luckily, that time, Japan already have a lesson study. The lesson study is a professional development mechanism by using a classroom is a place for teacher research. Lesson study have 100 years of history. That means, even more than before this problem-solving movement is happening, Japanese teachers examine their teaching practice by observing lesson each other, critiquing lesson each other, and then discuss what is the way to improve teaching and learning. That process will help Japanese teachers make this new idea about teaching through problem solving into a practice. And one of the reasons, I guess, I visit many countries, and many countries struggling not having this shift during 80s and 90s was because they do not have this professional development approach. Teachers are typically, after graduating the university courses or a licensure program, and then learn the theory and then touch upon some of the techniques, but let's go to the classroom. And once they go to the classroom, there are no further support, no further professional development. They have to close the door and then walk by himself, by herself. There are no update. So even like new ideas come from research, many teachers do not have access to these new ideas. But lesson study is a place where a teacher can gain their knowledge and then work together, critique, and then coming up new ideas. So, back in 1979, when I became a novice teacher, I was raised in traditional classrooms that the teacher lecturing and then show an example and then give us an exercise, and then the two mimicking what the teacher told us to do so by doing exercise. And then I became a novice teacher. And that time, the professional development focusing on problem solving. And then I had no idea, how can we do this? And then my mentor teacher say, you want to give a rich problem or task to the student and then spend entire hour of mathematics class by discussing about one problem. And I had no idea. I need 5-10 problems for one lesson. How can we do that? And luckily, I had opportunity to visit so-called research lesson as a part of lesson study. And then visiting the classroom, and then the novice teachers, she had like a second or third year teaching experience, but she worked together with their mentor teachers to coming up a lesson plan, and then teach a lesson using idea of teaching through problem solving. And that was very fascinating. Still, I remember that experience. The lesson was, the teacher is the teacher just put asking student to play a game of the ring toss. So like a pole in the classroom, and then the student line up straight, and then each student have a ring, and then the teacher say, well, we're gonna start a game, and everybody has a one ring and then toss to the pole, and then who got in the ring in the toss, the pole is the winner. And the students start complaining, the teachers. And at the very end of the line, like this, and then the student is start complaining, it's not fair. And the teacher says, why you think unfair? And the student say, I'm in the long distance. The girls in the center is advantage. So I don't like this game. And then teacher say, okay, I see your point. Why don't you discuss to make this game fair? And then students have discussion. And then they come up several different ideas. Like this way, oh, that they might be a good this way. Then some other students say, oh, it should be like this. And some students say, like that. And then class have a discussion. And then they come up a rope and then put the equal distance from the pole. And then it's end up, what's gonna shape? There is a conversation, and then this is circle. And then that time, student knew the term circle because they said everybody term. However, they have no idea about the definition of circle. And then the student realize, oh, the circle is a dot connected, the equal distance from one point. So the definition of circle actually coming from student complain about the game. And that was the introduction of the unit of circle. Teacher never ever said the definition. It was such a brilliant idea, and I was kind of shocked. And that's kind of research lesson is the teachers work together to try new idea and see other teacher observe and have some discussion. So that was, I still remember this. And now this task is the opening page of the Japanese textbook. So here, this is a ring toss game on the current textbook. So like a teacher try new idea in various different ways, and then through lesson study, and that's kind of proved the task is become a part of textbook. And then textbook actually begin asking student, how can we make this game fair? The lesson one. And that is kind of introducing a new concept or new ideas or even definition through teaching the problem solving. And then the Japanese teachers say there are 3 levels of teaching. The level 1, the teacher can tell student what's the mathematical ideas, basically lecturing this one. But many teachers do not think about this level 1 is a professional, because anybody who knows the mathematics can be a teacher. But the level 2 is a kind of beginning of teachers. The level 2 is talking about explaining student how this works, why this is important. For example, level 1 teacher can explain student how to multiply 2-digit multiply by 2-digit numbers. So you're gonna write this in the horizontal ways, and then you write it multiply ones and tens and ones and tens and tens, and then add them all. You have to follow step one by one, and then giving an exercise. That's a level 1 teacher. However, if the student say, for example, well, teacher, when we add 2-digit and 2-digit, you always told us you have to add twice, ones and ones, tens and tens. Why we have to multiply by 4 times? Why not 2? Level 1 teacher say, oh, don't worry about it. Just do it. That's the way that you have to do this. But level 2 teacher can explain why it makes sense to multiply by 4 times. That's the difference between level 1 and level 2. The level 2 teacher need a specific set of knowledge just for teaching. But the Japanese educators now, they do not think the level 2 is enough. The level 3 is like a teaching through problem solving, giving a situation for the student, and then student come up the ideas. Okay, when we multiply by 2-digit by 2-digit, we can multiply 4 single-digit multiplication to find the answer. We want the student come up these ideas by experiencing this thought process behind of this algorithm. So nowadays, after pandemic, everybody think about it. You can teach mathematics by using video. The video explanation available on the online free is most of them are level 1, just teaching a facts and procedure. Some of the good video is level 2. But level 3, but just showing the video, it's very difficult and almost impossible to get the level 3. The level 3 is more like a teacher-student interaction. Student-student interaction is required. So I teach undergraduate students who want to be a mathematics teacher. I said, if you are level 1 or level 2, we will not need you in the classroom anymore. You have to be a level 3 teacher. Okay, so the teaching through problem solving. The teacher introducing problem which students have never seen before. And if you give this problem, what's going to happen? There are several different solution methods coming because the student attempt in different ways. And then using these student ideas, teacher facilitate discussion. That is called Japanese teacher called neriage. It's kind of orchestrating ideas and then guide them to understand the new idea. So it takes about 45 minutes lesson, just one problem. And then summarize what you learn. That's usually the beginning of the unit. So for example, well, this lesson, the circle lesson, the textbook is introducing using these ideas. And then the sequence of the lesson continue like this. The lesson 1 is like, making a circle or the ring toss game to coming up the students see, that maybe the circle is an equal distance from the point. And then teacher is introducing, the lesson 2. Based on the discussion, teacher formalizing ideas to help student. By first, let's construct this circle by yourself to see if everyone got the circle or not. And then define formal mathematical definition coming to the lesson 2. And then after lesson 2, you're going to have lesson 3 to find more like how you're going to use this idea to solve this problem. For example, this task is quite challenging, simple but challenging. How you find the radius of this circle from the circle. Because in everyday life, there's a circle there. There's no radius or no diameters. How are you going to find this one? And well, of course, like a teacher gives it like the variety of tools, and then one way is cutting out this circle and then folding twice. And if you fold, there's a diameter. And then if you fold twice, it's gonna be a center and then radius. You can find it through this online activity, hands-on activities. That's a lesson 3. And then lesson 4 is how you construct a circle by using compass. This is something you need to explicitly teach it. Not the student may invent the circle or the compass. But then teach step by step. This is also quite important. And then use this one to create some of the interesting things. Also, the circle is the compass can be used to copying the distance. So kind of copying distance game. This is a kind of small cycle of the circle. And the lesson begins with teaching through problem solving, further the definition and further investigation and construction and apply to some other situations. This is a very typical flow of the Japanese lessons. So, how its impact to Japanese mathematics into this international the mathematical test. So this is the TIMSS, the third international math and science study, which was continued to 2003. This is like a trending mathematics science study 2003 result. By this time, the Japanese schools, most of the public schools is using teaching through problem solving based textbook, and then widely available in Japan. So this interesting graph is kind of from the data obtained from the TIMSS 2003, and then the vertical scale is average score of the TIMSS 2003, which means higher is better. And then the horizontal side is average percentage of TIMSS mathematics topic taught in the school either prior to or during the year. That means the TIMSS material is the same material sent to all these different countries. So the different countries have a different expectation in particular grade level. And how much test item given by the TIMSS was student already learned previously. So for example, international average, 73% of the contents was taught prior to the test. Yet, student can complete only 53% of the correct answer. Well, that's happened. Even though you teach how much, but the student can accomplish. In Singapore, 82% of the content the student already have learned. And then 74% was correct. In the United States, it's interesting, also 82% of the content was taught. However, only 58% was correct. The question is, where is in Japan? This is Japanese result. Students only learn a little more than half of the testing item. However, students correct 69%. So that means they learn very few. However, they can use what they learn to solve even the tasks that he or she have never seen before. I think that this is showing that one of the power of teaching through problem solving. Students are not afraid to attack a problem by himself, by herself, and then even get the correct solution. So this is a brief introduction of teaching through problem solving Japan, and then also some of the impact of this learning. Well, I published recently this book, The Teaching Mathematics Through Problem Solving, a Pedagogical Approach from Japan, as a book, and that have much more the example and then interesting the discussion about how this teaching through problem solving was developed in Japan, and then also how lesson study contributed to make this happen. So I want to end my presentation at this moment, and then if you have any question, please ask me.
Thank you very much for your presentation. Og vi siger tak til Takahashi for nu. Det kunne vi nok tåle at høre mere om det her, men vi må holde for nu, og så må vi have en lille snak med Takahashi omkring nogle af de ting, han har sagt. Ja, det var en interessant præsentation fra Takahashi om teaching through problem solving. Vi bruger under tiden betegnelsen undervisning gennem problemløsning på dansk, selvom vi godt kan have lidt forskellige tolkninger af, hvad det præcis skal betyde. Så lad os holde os til Takahashis begreb, teaching through problem solving, eller TTP, som vi også tit omtaler det. Vi har været så heldige at have besøg af Takahashi ude i Lyngby-Taarbæk Kommune, hvor han på Hummeltoft-skolen har undervist den samme klasse, 7. B, igennem 3 lektioner. Og der har han prøvet at demonstrere for os, hvordan teaching through problem solving kan se ud, og hvad der også er udfordringerne ved det, og hvorfor det har så stor værdi for børnene. Og det vil jeg prøve at spørge ham lidt til, og så efterfølgende så kommer der nogle spørgsmål, både fra mig og andre, som jeg vil stille ham, som han får mulighed for at svare på. Professor Takahashi, you have visited us in Lyngby, and at Hummeltoft-skolen you taught 7B for 3 lessons. I would like to first to ask you some of your general thoughts about this experience from your point of view.
Well, I have opportunity to interact with the 7th grade student. It was very rewarding experience in working with Danish student, and it was fun because the mathematics classroom should be created not only teachers and then mathematics, but also students. So I try to interact with your student, and then there was very interesting experience, and then I enjoyed very much.
And since you did not know these students, though it was of course also challenging, but this was actually part of the experience, that our Danish teachers, and we had also some observing teacher educators and researchers, we could see and we could participate in the actual process of working with how to develop the flow of several lessons, consecutive lessons. And it was you who insisted that we should try this through 3 lessons, not only 1 lesson or 2 or whatever. Can you explain why you insisted on 3 lessons?
Well, the level 1, level 2 teaching, that the teacher teach mathematics, explain mathematics to the student, maybe you can jump in and then teach 1 lesson. However, level 3 should be built onto student and teacher and mathematics. We need to work with student, and then the instructor, me, jump in the classroom and understand the student, and then I'm developing some of the kind of chemistry in the classroom, so that what I know about student, what the students should know, what I'm expecting, what kind of mathematics we want to discuss. In order to do so, ideally, the level 3 teaching should be taught by the classroom teacher or like a mathematics teacher who regularly teach student. But I'm not the classroom teacher. However, I want to share with your teachers about how the TTP classroom looks like. In order to do so, I just need at least 3 lessons. Hopefully, I could stay with those wonderful students a month or 2 months. It's going to be a fun and much more meaningful level 3 teaching I can share with the teachers. Yeah. But from my limited time, the 3 days must be the minimum.
Yeah.
No 1 day, of course.
And it was a very interesting experience. We are very fortunate that the 3 lessons were recorded on video, and they will be available on the homepage of National Center for Udvikling af Matematikundervisning later. You probably already know it, but it's matematikmedidaktik.dk. Let's proceed to a few questions. One of the questions that has come up is regarding the connection between teaching through problem solving and lesson study. you already mentioned a little about this in your presentation, but can you help us clarify what are the differences, or what is the connection between lesson study and teaching through problem solving?
Well, I wrote a book about teaching through problem solving, but the idea is not my own ideas. These are accumulation of researchers and then thousands of Japanese teachers for over 20, 30 years. And then that's a kind of tip of the iceberg. And then a lot of effort. So that is I want to make sure. And then how this wonderful idea is putting them together through multiple lesson study process. Team of teachers working together to design a lesson, the researchers contributing ideas, and then teach in front of the classroom in multiple times, and then kind of crystallizing ideas. Over the time, this task is very powerful when you're introducing circle. Now those are survived. There are so many good lessons, but it's not survived over 20 years of time. So that's for sure. If you do not have a lesson study, you cannot have such kind of collective work based on the collaboration among teacher, researchers, teacher, educators. So therefore, the lesson study is the necessary part to crafting teaching through problem-solving lesson. Many countries do not implementing the nice idea about teaching through problem solving because they do not have such kind of mechanism built into school.
Yes. So maybe it can be put like teaching through problem solving is the aim of what you would like to develop, and the lesson study is kind of like the tool or the framework for working with this development.
Yes.
Okay. There is also another question which is related to the connection between teaching through problem solving and the curriculum. So, of course, the curriculum could be like the national curriculum or the textbook curriculum, which I would like you to think about here. We have tried to, in different places in the world, people have experimented with teaching through problem solving. Many of us have this, we realize that it's not so easy if the textbook material is not made with this in mind. Can you say something about the meaning of the curriculum and teaching through problem solving?
Yes, the Japanese curriculum materials is, for example, elementary school curriculum. They have 6 different publishers producing mathematics textbook. All 6 has to be approved by Ministry of Education. But the Ministry of Education, when they review these contents, they do not talk about how you teach it.
No.
They talked about if that all these the standard, which is expectation, is satisfied or not. The teaching approach is more like how many hours you want to spend for a particular topic and which order you teach is really depend on, rely upon the curriculum designer's decision. Then the curriculum designer team, the team of the teachers, team of the educators, researchers publish the textbook. They have a specific agenda, and also they're going to test it out their ideas through lesson study process. Again, the textbook is accumulation of knowledge or expertise from variety of people, not some of the brilliant people's ideas. In many United States, the curriculum is developing only a few or 1 or 2 authors about, here is my idea, why don't you teach it? But the Japanese textbook is a mechanism from the field to kind of feedback to keep updating. So that's a kind of accumulation of knowledge. Because the textbook can be used in many different school settings, not like only a few brilliant people's ideas may not accommodate all these different things. Well, of course, there's some room to improvement, but it's very important to going through this kind of field. And if you are in Japan, many publishers who produce textbook is regularly attending lesson study and then look for some of the brilliant ideas, and then to make this happen.
Yes.
So I think that's a relationship between the teaching through problem-solving movement, gain teachers' knowledge and expertise, and then also kind of contributing to the quality of the textbook. So the one of the example is like I observed a circle lesson back in late 70s is now used in the Japanese textbook after years of this.
Yes. I also noticed that like you said, there are 6 different publishers in Japan who has the approval to publish mathematics textbooks. If you compare many of them, they are different, but there will also be many similarities. And I suppose that it has to do with, like you say, it's the wider community in Japan which has developed this knowledge, which is accumulated. Mm-hmm. Yes. One of the things that many people who have observed TTP lessons say, and we saw this again during your visit here at the Hummeltoft School, is they observe that the pace of the lesson seems to be very slow. At least in the crucial sequences of the lessons, you're working very long time with the same problem and having a student spending quite a long time on working on this the problem. I came to think that earlier I've seen from one of your presentations years ago that you make a reference to J.W.A. Young, who said something like 10 pages read and understood is worth much more than 100 pages read and not understood. Could you give a comment to the combination of those two situations?
Well, actually, the J.W.B. Young, they focus, he emphasizing that it's very important for you to actually investigate the materials. That's like independent work is much more powerful than passively listen to somebody's explanation. And that book was written in 1906. It's like more than 100 years ago. Mm-hmm. And then he argues that that's the reason why we teach mathematics for every single the people in elementary and then secondary schools. Because we want people to experience the thought process and with deeper understanding. Which is the teaching through problem solving. As I said, the circle activities spending 1 hour, that's been done. Or if teachers say, here's the definition of circle, this can be done in less than 2 minutes. Yeah. But the actually walking through this experience is much important. And also, even like a deriving formula for finding area or particular shape, if you compare multiple different approaches to see what is the similarity and difference, what is the shared idea, which is much more powerful than finding an area of bunch of similar problems. So the one problem, multiple approach, have some discussion, help them. What is the essential element? What can be different? What should be similar? And that helps students to become much more flexible. And then once you understand the formula, for example, do you remember that formula for finding area of trapezoid? Like the top base plus bottom base and multiply by height divided by 2. And sometimes people easily forget. And then, I need to memorize this again. And then what is the formula for finding area of parallelogram? Base times height. What is the formula for triangle? Base times height divided by 2. Actually, all these 3 are very similar. Yeah. And then triangle parallelogram formula can be solved, can be find the area by using trapezoid. If you know some relationship, you don't have to memorize one by one. That saves a lot of energy. So understanding is so powerful.
One of the things that springs to mind when you talk about TTP and when we observe TTP lessons is that it seems that it seems that this is actually kind of an implementation of the ideals and also the knowledge we have about children's learning of mathematics. I mean, it's very old. I mean, it goes even back to Socrates that we cannot actually teach something. We can help them to learn it, but we cannot teach it to them. And we have heard a number of thinkers and researchers through the years point out ways of how we actually learn and what is necessary, which kind of processes is necessary to learn and obtain a solid knowledge. And this seems to be what we see here. What is a connection, or is there a connection between Western educational thinkers and your practices in Japan?
Well, of course, the Japan learned a lot from Western world. And many people say East versus West. Eastern mathematics is much, the Asian is better in mathematics, but it's not true.
Okay.
And also, even Asian countries, that how you teach mathematics is very different from China, Singapore, Korean, Taiwan, Japan. It's not the same. And then Japan is one of the country, it's very good. They just learn from variety of theory and then research, and then make it happen in very practical way. I think that's the strength of the Japanese culture, to my view.
Yes.
And the lesson study is a way to make all these nice ideas into teaching. Because the Japan is really care about education, and it's been a long time.
I think this leads us to the question of discussing more. Well, you already said a little about it, but how come that Japan is the only country where we see a systemic use of TTP or teaching like this? I mean, almost all over the world, we are discussing that we need reforms because our students don't learn enough, and we want them to learn. Sometimes we don't want them to learn more. Other times we discuss we want them to learn better. We want them to understand, and so. But in Japan, you have a totally different approach to teaching, and you seem to be one of the only countries in the world where you have this, at least at a nationwide level. So, how come the rest of us have not done the same?
Well, that you highlighted other country in Japan, but within Japan, this dilemma still exists.
Okay.
Because many elementary school, they implementing idea of teaching through problem solving in very regular basis. However, high school is not. High school is most of the high school classroom is focusing on teach by telling, teach by lecture, teaching through lectures. Now, the many high school researchers in focusing on how to shift the Japanese high school mathematics education into more investigation, more problem solving, and which is even 20 years after that the Japanese elementary school shifted. I think that there are big discussion about within Japan, how can we make this happen in high school too? So it's not only outside, but the Japanese elementary school is kind of lucky to have a lot of activity in the lesson study. But high school, until recently, there are not much lesson study. Therefore, they are having the same difficulties that the other countries facing right now.
So does it mean that in Japan you have that the high schools are looking to elementary schools as to how can we develop teaching, or are they trying to develop their own ways?
That's a good question.
Thank you.
This is an ongoing process. So we look for it. Yeah. And if you search internet, there are a lot of the good project happening among high school, but it's only a small portion of high school in Japan.
Okay.
But they've been doing a very innovative.
Yes.
So from the U.S. perspective, there are a lot of spot of excellence. Some high school did a brilliant job. Some teacher did a good job. But the systematic system of excellence is another layer.
Yeah.
It's very challenging. So in Japan, the high school is, you see a spot of excellence, just like the US or Denmark or some other countries. But to make it the system, it takes more time to do that.
Yeah. Okay. So, in order to work with TTP in countries like Denmark or the US, you have a lot of experience especially in the US, but in many places in the world. It seems that one of the questions that very often comes up, something like, do you have a recommendation? What is your suggestion for us if we want to implement TTP, or if we want to learn how to do TTP? What is your recommendation? What is your suggestion to how to either approach it for the first time, or if in some cases people have already started, how should they progress? What can they do to progress from the initial difficulties and so? Do you have some general recommendations for that?
Yes. First of all, we need to support teachers to give them opportunity to update their knowledge and then develop their expertise. Because societies keep changing, a new curriculum, new expectation is coming. However, many countries, unfortunately, they do not give the time and then resource for each individual teachers. Of course, there are some teachers, they spend their own money, own time, own effort to improve and include. Those are good teachers. Again, that's a spot of excellence. You see in many countries, very nice. And of course, we can give some reward to those teachers, highlighting their accomplishment. But it is good. But to make it systematic, these are only probably less than 10% of the teachers who worked.
Yes.
How about the rest of the 90% of teachers?
Yes.
Right? To make this happen, you need to allocate more resource for teachers. Time to collaborate. Time to update line. Because reading a new idea from the book does not help them to use this idea in everyday basis. You need to do some experience and critiquing each other, working each other, observing each other. Unfortunately, many countries do not see that's a necessary condition to be a good teacher. So the teacher is not born as a good teacher. No. Everybody can be a good teacher if you work together, collaborate to discuss each other as a professional. Okay, so establishing the system to nurturing, encouraging teachers to improve is my strong recommendation for all the countries.
Thank you very much. I was also thinking that. So you recommend us to develop these the possibilities. So this is of course a major obstacle for us that we don't have these structures. But other than that, let's play a game. Let's say we did implement those structures, and the teachers were willing to, and they would spend time on this, developing a new way of thinking regarding the teaching through problem solving. What do you see as a main obstacle for let's say, if I as a teacher should develop my teaching? What is my main obstacle?
Well, the existing culture among teachers is if you observe other teachers teaching and give some suggestion, and often teachers do not distinguish teacher and teaching. We're going to have an opportunity to discuss teaching. But if you talk about teacher, you are a good teacher, you are a nice teacher, those are more including some personality or personal preference. But the teaching should be a professional expertise, professional exercise. It should be, that we should help teachers to distinguish between teacher and teaching.
Yes.
And then talk about teaching. And then how the teaching impact to the student learning. Even like you have nice teachers, but does not impact the student learning, you need room to improve. So the teaching is quite important. Also, the curriculum materials. Who is not supporting teachers to teach for nurturing student developing mathematical process? You need to update this one. But everything is happening in the classroom. So without observing classroom, to discuss all these in outside may not productive. So
I think here by the end, I would like you to present some of your data. You have some very impressive data from one of your projects in San Francisco, where you've been working with developing TTP by the use of lesson study. And it has some very good results. But one of the things that we talked about, which I personally find very interesting and also very important, is that in the beginning you actually saw a decrease in the impact. So will you share with this data with us?
Sure.
Yes.
Okay, well, this data is from the San Francisco Unified School District in the United States. And we had a 5-year pilot project of teaching through problem solving and lesson study. And then this is the data from one of the school and, struggling to improve teaching and learning mathematics. The first year is 2014 to 2015. The district, the standard, the many students did not meet the standard expected. And the district average was 50% of the students met the standard. And then that school is less than 20% of the student only that met the standard expectation. And this is all the subgroups: African American student, and then Hispanic Latino student, English learners, low income student. They have all this difficulty and much lower than the district standard. But as you can see in the graph, the next year was declining because many teachers struggling to understand that how you teaching through problem solving. The lesson study process, there are a lot of discussion among teachers to understand each other. And then the year 3, now all this, the group is jump up, and then even like the school as a whole, the district, the standard met was at about 50%, but they jump into less than 20% to more than 30%. But still, there are a lot of room to do this. Particularly, the African American student who was lowest performance within the school is jump up to 40% from less than 10%. And then the fourth year, they're stable, kind of, the stable in the grade. And then year 5, now you see a real flourishing this result. And all these, including all these subgroup, the school's score is beyond the over the district average. And that is, it takes 5 years. However, it's really people was very pleased that one of the low-performing school become much higher than the average of this. Then particularly the African American student, they have only 10% of the student met the standard. Now it's become more than 50% of the student, that met the standard. That's a kind of one small example. But currently, those schools are, working hard to catch up from the some declining from the pandemic, and then they are working very hard to make this continuous growth.
Yeah. Yes, thank you very much. And now, as you said, this was a school which was before already kind of low performing, but I think it's very important. We should not we should not deceive ourselves to think that you can only use TTP for raising the performance of formerly low-performing students. There's a lot of research also indicating that this kind of teaching actually helps all kinds of students at every level. One of the things, like I said, which caught my eye on this was how in the first year, after the first year, you actually saw a decrease, and then it needed some patience, and I'm sure it has been also a lot of hard work and a lot of support from people like you, but also other people. And but it's nice to see that with good steady work you can get a long way. So.
One thing that I want to add is many people say that the teaching through problem solving works for the high achieving student to deepen their understanding, much more kind of the creative. However, this data shows that the low performing school is really helpful. And then, as you said, the learning curve is not always linear. It's more like exponential. But the first 2 years, 3 years, you need to kind of be patient. And then now, this effort is going to pay off. And then this is not only the entire group, but also each individual level student, grade 3, grade 4, grade 5. When student going up, those low-performing student is growing. Yeah. So they not only catch up, but kind of much more the improvement, you can see it. But unfortunately, many teachers, or particularly the policy makers, are not patient enough, and then need a quick result, and then soon to dismissed. Even teacher and student working very hard to waiting for the big jump.
Yes. Well, this is of course a situation we also know in Denmark. Takahashi, I want to say thank you very much for your visit here, for joining our webinar and the teaching some of our students in Lyngby. And I will just make some closing remarks in Danish. For jeg vil bare slutte af med at sige, som jeg også nævnte før, at noget af det, som virkelig har slået mig og andre folk, der interesserer sig for de her ting og studerer, blandt andet teaching through problem solving, det der med, at når vi ser undervisningen udført på den her måde, så ser vi jo vores egne idealer omsat til praksis, og i høj grad den viden, som forskning igennem mange årtier på tværs af landegrænser og kontinenter har udvundet omkring børns læring af matematik. Vi ser det jo implementeret i praksis, hvilket er helt fantastisk. Vi er godt klar over, at det ikke er så enkelt, men det er virkelig værd at dykke ned i. Så det er en stærk opfordring herfra til at kigge mere til det. Og det er også en opfordring, som ikke bare bygger på, at det er spændende, men også, at vi har jo nogle generelle udfordringer, vi står for i forhold til vores undervisning. Vi er jo desværre, er det sådan, at hvis vi kigger på resultater for danske elevers matematikpræstationer de senere år, så kan vi jo blandt andet se, at igennem folkeskolens prøve efter 9. klasse, at for eksempel mellem 20 og 25% af eleverne har svært ved, eller ikke svarer rigtigt på det subtraktionsspørgsmål, der altid indgår, og også omkring et tilsvarende tal for eleverne altså på division. Det er bare nogle få eksempler, men det går jo desværre igen. Så der er ikke nogen tvivl om, vi har grund til at gøre noget, og måske var det her noget, vi skulle kigge noget mere til.